Hi, everyone. Thank you so much for being able to listen to my presentation. So just to start things off, I would like all of you to think about your favorite memory. What comes to mind? In fact, many of our memories develop as photographs taken by our eyes, which I like to call our biological cameras. And unfortunately, these cameras malfunction in children with a congenital rare eye disease known as KCNB2 retinopathy. They lose parts of their sight, which leads to missing information in their visual field and incomplete photographs. And this happens because of dying photoreceptors, which are the light sensing cells of the retina. These parallel with the light sensors you would find at the back of a camera. Photoreceptors have channels on their membranes to help transform light into visual signals that we can send to the brain. Mutation of these channels disrupt their function and consequently vision. It's not clear why this happens, and we believe there is a potential to help patients who suffer from this disease. And as a first step towards that goal, we aim to characterize this degeneration. And so, how do we go about doing this? Our lab created a mutant KCNB2 zebrafish model, and we use zebrafish because their eyes are very similar to ours. Our model allows us to examine disease progression and characterize photoreceptor development across the zebrafish lifespan. So far with our research, we found out that although young mutant zebrafish possessed functioning photoreceptors, the endings, known as outer segments, actually degenerated slightly. We decided to investigate the potential of our model by studying adult mutant zebrafish and look for any long-term consequences of this disease. This summer, my aim was to characterize these adult zebrafish photoreceptors using ERGs and microscopy. ERGs stand for electron retinogram, and it's where we record the visual response to light. In my work this summer, KCNB2 mutant zebrafish had delayed and diminished responses compared to their wild-type counterparts. We also used immunofluorescence and transmission electron microscopy to view what the photoreceptors look like in the retinal layer. Our results revealed that the outer segments of mutant zebrafish continued to degenerate further down the full photoreceptor. So we gathered more data and looked at photoreceptors later in life. What now? Combined with the results on younger fish, we are now able to conclude that morphological pathology of KCNB2 retinopathy begins at an earlier age before we see any functional changes. Although more research still needs to be conducted, the work done using our model is useful in creating a potential intervention for KCNB2 retinopathy patients before photoreceptors begin to malfunction. Essentially, we'd be helping to preserve the light sensors of our biological cameras. Down the road, this work will be very important in further understanding photoreceptor health and fighting vision loss. Thank you for listening.